No, sir.
Yes. So there is a class, there are 27 boys, 14 girls. The teacher wants to select one boy and a girl to represent the class for a function. So basically, there's a team of two persons in which there is one boy and one girl. In how many ways can the teacher select? So basically, for selecting a boy, there are 27 ways. Like, because there are 27 boys also. Okay, for selecting one girl, there are 14 girls to get selected. So there are 14 ways to so that to make a team with a girl. Okay. Now with like let's say with one boy, let's say there are 27 boys having name as numbers 1, 2, 3. So the boys are having chest numbers from 1 to 27. Let's say with the first chest number 1, boy chest number 1 can have girl number 1 as her team member, girl 2, or girl, how many girls are there? 14. So with B1, there are 14 options. With B2, there are 14 options as well. So basically, so for making a team, the task of selecting a boy or a girl is dependent, okay, is interdependent on each other. So there it's an dependent task. So the total number of ways to formulate a team will be 27 into 14 because the tasks are dependent. Okay, selecting the boy, selecting a particular girl will will happen to make a same team. So they will depend on each other. Okay, that's why they are dependent events, and that's how we have multiplied the number of ways for both of the particular tasks. Clear, everyone?
Yes, sir.
Is there any doubt? The answer will be 4 into 7, 8, carry 2 into 1 into 7, carry 2, 1 into 7, and 4 into 8, 7, 15, 15 into 7, and 1 carry 2 into 1, 2, 2 plus 1, 378. I hope you know this method of multiplying two digits number. Do you? If not, we will cover it in a later part of the class if there is more time. So is this question clear, everyone?
Yes, sir.
Great. So now let's move on to the next. There's one more example. A hole has 12 gates. In how many ways can a man enter the hole? Through one gate to come to like go in, and he should come out via another gate, a different gate. So that's the question. Okay, so let's say if there are 12 gates, there is the person Sonu. He wants to enter any particular hole. The hole has 12 gates. Okay, so he has 12 choices first, 12 choices to enter, 12 number of ways to enter. Now, once he have entered the hole, there are also 12 gates, but he cannot get out from the same gate that he was entered in. So basically 12 minus 1, he have now 11 ways to exit. Okay, so there are 12 ways to get in, 11 ways to get out. Now, the total number of ways in which Sonu can enter and exit will be the multiple of both of the number of ways. Why so? Because the event of exiting the hole will depend on the first entrance. Because if Sonu entered through gate number 3, so now Sonu will not be able to exit through the gate number 3 because of the given condition. So he will have 11 choices other than Z3. And so 11 choices are dependent on the first choice that he made, that through which gate he will enter it. Okay. So similarly, for every exit, the exit will depend on the entrance from which gate he entered. So that's why these two particular event of entering and exiting are dependent events. Okay. If they are dependent events, the number of ways are going to total number of ways to get in and out of the hole will be 12 into 11. That is 132. Is that clear, everyone? If there is any doubt, you may ask that why these two events are dependent events. Any doubts?
No, sir.
Let's take an example that he entered through Z3. Okay, he stayed there. Now he has 11 choices left other than G3. That's one case. If he would have entered through G4, then he would have other 11 choices other than G4. So basically what I'm trying to say, the event of exiting is depending on the event of entrance. If he was having a choice of exiting through any of the gate, in spite of the fact that he entered through any gate, so the events will become independent, and then total number of ways will be 12 plus 12 because they are independent events this time. So the number of ways in that particular case will be 24. Are you able to understand this fact? Clear, everyone?
Yes, sir.
Okay. Let's now take one more example. In a class, there are 25 students, not as intelligent as you. In which 15 boys and of course less girls are there. The class teacher has to select a class leader, a monitor. It can be a boy or a girl, doesn't matter. In how many ways the class teacher can appoint the class monitor? Is this question clear, everyone?
Yes, sir.
So do anyone have the answer? So just tell me one thing, okay? So let's say if there are 25, class of 25, in which there are 15 boys, 10 girls. Okay, and one monitor is needed to be selected. And it doesn't matter that you can select any boy, any girl, doesn't matter. So for selecting boys, how many number of ways are there? Let's say selecting a boy monitor or a girl monitor. For selecting a boy monitor, how many ways are there? How many selections can be made? Look, like the selection is only one, but how many choices are there? There are 15 boys, so there are 15 choices, I guess. Yes.
Yes, sir.
And please, everyone participate, everyone keep on responding so that, okay, 15 choices for making a boy monitor, or for making a girl a monitor, there are 10 choices. And these two particular events are independent in nature because they are not depending on each other. So we can sum them. The total number of ways to select a monitor is 15 plus 10, that is 25. Okay. Now I have gone through this particular method just to understand you the fundamental principle of counting. Otherwise, also it was simple thing that there are 25 choices and one has to select it. So there are 25 ways, but just for the sake of concept. Please read the solution and slide again. Clear any doubts?
No, sir.
Okay. There is a similar question. Let me just narrate it for you. That there are 4 students of physics, 4 physics students, 6 chemistry students, and 7 mathematics students in a race for winning the gold medal. The gold medal is unique. In how many ways one of these gold medals be awarded? So whether a physics student will win it, or a chemistry student, or a mathematics student. So the event in which the physics student will be winning it will be independent of others. Okay. So 4 for physics, 6 plus chemistry plus 7, basically 17 ways to, there are 17 students, 17 ways in which the selection can be made for giving the gold medal. Clear? Clear, everyone?
Yes, sir.
Now, permutation. Basically, first we'll discuss the bookish language, the bookish definition, which is important for sure. Permutations. When you will search for the meaning of permutation, it's just the arrangement of things, right? So it stands for arrangement being total number of elements, objects that you're discussing about, the same. Okay. And also there's one more definition. The permutation is the number of permutation, number of arrangements. The number of permutations, or you can say arrangements of n different things. Taking r at a time is denoted by NPR. Okay, I guess things are not that much clear. So let's use the layman's language and understand it from a layman's perspective. So basically, if there are r things, r number of things, let's say there are r number of space, there are r number of space on which we have to arrange r elements. We have to arrange r elements out of n. So basically there are total, let's say there are total n elements, out of which we have to select r elements, and then we have to arrange them on r spaces. So the total number of ways that will be discussing in permutation will be that first we will select r elements from n elements, and that is total element. And second step is arranging r elements at r spaces, at r places, basically interarranging them. Basically, if we have, let's say if we have three books, let's say there are three books of English, Hindi, math. Okay, so in first I can put English book, there are on that particular book, the Hindi book, then comes the maths book, the big one. Or I can put the maths book at the bottom, then the English book, then the Hindi book. So that's basically the arrangement, the inter-arrangement. So how many spaces are there? There are three positions. 1, 2, 3. How many elements are there? There are three elements. So that's called an arrangement of three elements on three spaces. Is that clear, everyone? Clear? Please stay focused. It's an important chapter. Let me repeat that the number of, we will be discussing the number of ways of selecting R elements from N elements and arranging R elements at R spaces. Basically, that is what we are going to do. Okay. So let me explain the map once more. Formula. The NPR, in which we will be selecting R elements from N, and after selection of R elements from N, we'll be interarranging those R elements. Okay, great. So its formula is n factorial divided by n minus r factorial. Okay, so that is the formula where n is the total number of elements or things, and r is the things, number of things. Number of things or elements to be arranged. I guess the definition is clear now. What is a permutation? Is that clear, everyone?
Yes, sir.
Okay. So first, let's discuss about some basic concepts. So let's say if you were to make a flag, okay, A flag having let's say four colors this time. I'm not coloring the flag. I'm just telling. Basically, there is four space. Okay. So you can fill colors in between these four spaces. How many spaces are there? There are four blank rectangles to fill in. So we can call it four spaces. And you have four different colors. Red, blue, sorry, that's violet, right? Red, violet, green, and orange. Yellowish orange. Anyways, so there are four colors and four spaces, right? So how many number of ways can be there? So for the first flag, and you have like limited, you can only fill one color once. You cannot use same color in two space. Okay, so that's the rule. Okay, so in the first, for the first space, how many choices do you have? How many choices of colors do you have for the first space? How many colors are there? There are four choices. One, two, three, and four. Isn't it? There are four choices, right? Are you with me?
Yes, sir.
So there are four choices to fill in the first flag. Let's say we have filled the first space with red color. So out of four choice, we have utilized red color. Coming to the second space, how many choices we had for the first space? There was four. Okay, we have utilized one. Coming to the second space, let's say how many choices are there now? One, two, and three, right? So there are three choices for the second space. Let's say we have used violet color this time. Okay, nice. Now for the third space to fill in, how many choices are left? We have two ways, two choices. Let's say we use orange choice this time. We have only left with one choice and one color. So only one choice is left, green. So my point is to arrange four elements in four spaces will have to, the total number of ways will be these many. Now to sum it up, let's count it using the fundamental principle of counting. Now filling the red color is dependent on other events because if I have utilized one particular color, let's say red, then we will have only three colors left. So of course they are all filling all these four spaces are dependent event. Why dependent? Because we had limited number of entries, right? There were only four elements to get arranged with. Okay, so if they are dependent events, the total number of ways is 4, 3 into 2 into 1. The multiplication is there because of the dependency of the events. Great. So can we write it as 4 factorials? Yes. So now can we conclude that to arrange R elements on R space, or instead of space, let's use place word. Place word is better. On R places, the total number of ways is R factorial. Do you agree with this particular point? Yes, there will be r factorial total number of ways because of the discussion that we just had in the previous slide. Yes. Okay, great. So that's the permutation in which basically we'll be counting that total number of ways to first select r elements from n, and then we are interarranging them. That is my point. Great. So let's now discuss more about the formula. Formula is for permutation NPR, that is n factorial divided by n minus of r factorial. Let's discuss this formula ahead. Great. So the question is, find number of 5 letters, 5 letter word with or without meaning. We do not care about meaning. That can be formed out of the letters of the word. Jadoo, where the repetition of letters are not allowed. So when repetition is not allowed, we cannot use the same particular element twice. Okay. So we have to find a 5 letter word. Now please heed that how I approach this particular question. So if there is a 5 letter word, let's write 5 places that are needed to be filled to make this particular word. Okay. And what are the total number of elements that we have? Magic. So how many elements are there? 1, 2, 3, 4, 5. There are 5 elements. No element are same. Okay. So for the first space, how many choices do I have? For the first place, how many choices are there? Come on, tell me. For filling the first place, how many choices do I have? If I have 5 elements, M-A-G-I-C, so I can fill
Five.
it with 5 letters, right? Okay. After using one letter, let's say if we have used any letter, let's say A has been used, just for assumption. How many letters will be left for the second place? 4. Similarly, 4 choices for the second place. Now that 2 places have been filled with 2 letters, how many choices do we have for filling the third place? 3. Now 3 places have been filled with 3 letters. There were total 5 letters. So only 2 letters are left to be filled in the second place. So 2 choices are there. Now 4 places are filled with 4 letters. There were total 5 letters. Only one letter is left and only one space is left. So one choice, one place. Okay. So these are all dependent events. Why? Because we cannot repeat any letter. So if we have used any particular letter, the second event will be affected by the previous event. So they are dependent events. That's why we are going to multiply the number of ways. That will become 5 factorial, which is 120 known to us. Clear everyone?
Yes, sir.
Great. So there is one more very basic question that is coming. It is given that there are 20 buses. Between, let's say, Chennai for relevancy and Rajasthan. In how many ways could the round trip from Chennai to Rajasthan be made so that you take the same bus, or there are two parts for this question, a different bus? Yes, that's the question. Let me repeat the question. There are 20 buses running from Chennai to Rajasthan. How many buses are there? One, two, three, four. Similarly, 20 buses are there. And to and fro. So 20 buses going will also come back. So there are 20 buses coming also. Now, how many ways could the round trip? Round trip means going from Chennai to Rajasthan and Rajasthan to Chennai be made such that we'll have to go in the same bus. So how many ways are there to going in the same bus and coming back in the same bus? Okay, so let's discuss about the solution of the first. So for going, how many choices I have? There are 20 buses. So I have from for going to Chennai to Rajasthan, there are 20 buses. Now, when I have to return from Rajasthan to Chennai, I have to take the same bus. So I have only one choice. Why? Because I have taken a particular bus when I came from Chennai to Rajasthan. Okay. Let's say I have chosen a pink color of bus, or let's say let's give the bus as a chassis number 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 2, 20. So let's say I have chosen 17 number bus for coming from Chennai to Rajasthan. Now when I have to go from Rajasthan to Chennai, I have only one choice, that is the 17 number bus. So how many choices are available from going from Rajasthan to Chennai? One, when I have to take the same bus. Okay. Now, these two events, going and coming back, are dependent on each other because the number of way for choosing a bus was dependent on which bus I took earlier. So the number of ways will be getting multiplied. The number of ways will be 20. Is that clear, everyone?
Yes, sir.
Now, if we talk about if we were if we had to take a bus from Chennai to Rajasthan, there are 20 choices available. Great. When I have to return from Rajasthan to Chennai, now I will have choices. Definitely, I'll have choices, 20 choices, but as per the given condition, that I have to board a different bus. So, out of 20 bus, I have chosen one bus for coming to Rajasthan from Chennai. Now, how many buses are left? 19 buses are left. Now I have to use the different bus. So I have to exclude that particular one case from 20. So I'll have 19 buses. And this particular event of choosing 19 buses is also dependent on the arrival. So the number of ways will get multiplied and this will become 380 ways. Clear everyone?
Yes, sir.
Yes. Now let's say if we have to find out just total number of ways, in spite of the fact you take the same bus, different bus, doesn't matter. Let's find the total number of ways. Then what will be the answer? Can anyone? So how many ways are there for going from Chennai to Rajasthan? 20 bus, right?
20.
Now, how many for Rajasthan to Chennai? 20 same because we do not have any allergy with any particular bus. Now, as these two events are happening one after the other, one event is going to affect the other because if we see it collectively, let's say if we have chosen just 17 number bus for the arrival to Rajasthan, and now we are choosing another bus 18. So in when we look from a bigger picture, 17 and 18. So these two are coming together to make my one route. So they are dependent events for sure. So 20 and 20 will get multiplied. Total number of ways will be 400 because they are related events, dependent events. Clear everyone? And I could also have just added them, both of them. Clear? Any doubts?
No, sir.
Hmm. Okay. Now this is a very important question. Now we have a Vitara Brezza, brand new car. So how many people can sit in a car? A Brezza, Suzuki Vitara Brezza.
Why, sir?
Wow, fast reply. So that is the seat. There are 5 seats. Okay. So in how many ways can 5 persons sit in the car so that 2 persons? Let me write the question. Okay. That is going to be an important question. So tell me how many of you can drive? Is there anyone who can drive? Or are, or is everyone like me? Okay, silence. So, in how many ways? Okay, one more S. That S denotes my name. Such it. Anyways, in how many ways can 5 persons sit in the Vitara Brezza so that 2 persons, including the driver, sit in the front seat and 3 persons sit in the back seats. So we have total 5 persons. Okay, we have total 5 persons, out of which two cannot drive. So let them call non-drivers ND, and 3 persons who can drive. Okay, let's denote them by D. So how many ways we can make them sit? Great. And we know that on this particular sheet, the driver has to sit. The person who knows the driving. Okay, so let me redraw the seat structure. So this is the driving seat. Okay, how many vacancies are there for a driver? How many choices do we have? We have total 5 choices, out of which 2 people can drive, 2 people cannot drive, and 3 can drive. So how many persons can we are able to are worthy to sit on this particular seat? Come on, that's a very simple question. Only 3, right? Only because 3 people can drive. So we have 3 choices for this particular seat. Okay. How many choices for this seat? Anyone can sit here, right? Anyone can sit here. Is there any particular situation?
5.
Yes. Not 5. Why not 5?
So
Because
3,
one person.
1 will be sitting in the driver's seat. So 4.
So how many choices do we have?
4.
Yes. 4. Now, how many choices here? Out of 5, 2 persons have already seated. How many choice for this particular seat? Window seat. The person who vomits. Not actually there. So only 3 persons have left now, right? Because 2 persons are already seated. The driver on the person or the co-driver seat, right? So now 3 seats have been filled with 3 persons. 3 persons have been sit out of 5. 2 are left. So 2 choice for this particular seat and 1 choice for this particular seat. So all are dependent events, right? All are dependent events. So to find the total number of ways, what is asked? The total number of ways. So the number of ways will be getting multiplied because of dependency of the event. 3 into 4 into 3 into 2 into 1. That is basically 4 factorial, which is 24. 3 into 24 is, can you tell me what is 3 into 24? 72 is the answer. That was a good question to make your understanding sharper. Now remember that the number that I am writing here with the places are number of choice. Available to fill in this place. Is everything clear, everyone?
Yes, sir.
Yes, well, yes. So that's how the questions are solved, and you have to solve them in particular steps. We have first filled the driver seat because of a reason. because we were not able to decide if we were making a person sit on this particular seat, whether that person is a driver, is that person who knows driving or not. So let's first fill the seat, which is the, let's say, there was limited reagent in chemistry, right? So everything depended on that. So this is that place. This is limiting our choices. So we'll fill it first. Okay. So wherever there is any particular spatial position, we'll fill that first. Clear, everyone? Yes. So let's now move ahead. The next question. Eight children are to be seated on a bench. Okay. So now we have certain conditions. In how many ways can the children be seated? Second part of the question says, asks how many ways, how many arrangements are possible if the youngest child sits at the leftmost end of the bench. So that is the question. Is the question clear, everyone?
Yes, sir.
So there are 8 children that are to be seated on a particular bench. So on a bench looks like generally like this. So this is the first place, second place, third place, fourth place, fifth place, sixth place, seventh place, and this is the eighth place. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 places are there. Basically, bench do not have any segregation, but we are like just assuming that there are 8 places. Okay, in the first condition, this is for the second. Anyways, first condition, we have to just make the children sit. Doesn't matter. So for the first place, there are how many choices? 8 choices, 7 choices, because one person has already seated. 6 choices, 5 choices, 4 choices, 3 choices, 2 choices, 1 choices. Basically, multiplication of all will become 8 factorial. That is the answer for first. Is there any doubt, anyone? We are basically arranging 8 persons on 8 places. So that is very simple. R factorial should be the answer. When we are arranging R persons or R elements on R places. So R factorial is the total number of arrangements that we can make. Clear?
Yes, sir.
Yes.
Yes, sir.
R elements, R spaces, places. Total number of arrangements will be R factorial. That's basic. The concept of this particular basic formula is I have already talked about multiple times. In the second, we have to find out how many arrangements are possible if, now there is a special case, the youngest child sits at the leftmost end of the bench. So the youngest child will be only one superlative degree. The best is one, the worst is one. Okay. So the youngest child sits here on the leftmost end. Okay. So now how many? There were 8 children, out of which one has seated. How many children are left now? 7. So how many choices to fill this particular space? 7. Now 6. 5. Already 4 has set it out of 8. So 4 choices, 3 choices, 2 choices, 1 choices. Total number of choices will be getting multiplied. There is only one choice for sitting the youngmost student, youngmost children. So 1 into 7 into 6 into 5 into basically the 7 factorial. 1 into 7 factorial is what? 5,400, 5,040. And 8 factorial is 40,320. I didn't remember 8 factorial. I have cheated it from the notes. 7 factorial is I know. Clear? Is the question clear, everyone?
Yes, sir.
The notes of the same slides will be provided you in the WhatsApp group. If you have any doubts, you may ask later also. Shall we conclude the class now? Yes.
Yes, sir.
Yes, sir.
Thank you, everyone. Jai Hind.